So, hi everyone, I'm here to present my solution about the inverse G transform of the following system. So, number one is find inverse G transform of the system xz, which is 10z over z squared minus z plus 1. So, first is we need to find and multiply this system in sign A from both numerator and denominator. So this is okay in a law or manner in mathematics because this is only equal to 1. So next step is to arrange this system in a manner which is familiar in Z transform table. So arrange those system which is familiar with this Z-transform table. So this system is familiar in line 9. So arrange this. So by coefficient matching, if alpha is equals to 60 degrees, then we can say that 2 cosine 60 degrees is equals to 1. So if this is equals to 1, so we can put this into here variable because this is only equal to 1. So um, next step is substitute alpha 60 degrees into the system. So substitute, also substitute this into here. Okay, then the next step is find the z and I mean find the inverse z transform of this system in this z transform table, which is in a line 9. Okay, then simplify those following system. So this sine 60 only equals to 0.6 and 866, then this. Okay, so the answer for this system is 11.547 sine and 60 degrees UN. Okay, then number 2 is find inverse Z transform of the system xz, which is equals to z raised to the power of 4 over z minus 1 plus z raised to the power of negative 6 plus z raised to the power of negative 3 over z plus zero point 0.5. So the first step is to multiply this system into z. Okay, multiply this system to z so that we can arrange this manner which is familiar in Z transform table. Okay, this system remains still and this system will multiply to Z. Okay, so arrange this manner which is familiar to Z transform table. Okay, so the next step is simplify this following, which is equals to z raised to the power of negative 5. Also this and this simplify, which is z raised to the power of negative 4. Okay, the next step is to find the inverse z transform of this following. As you can see, this system is in time shift property of z transform. So we need to time shift this. Okay, this which is equals to u n minus 5. Okay, is time shift property. This is also in time shift property, which is derivative of n minus 6. Okay, this is also in time shift property. So which is equals to negative 0.5 raised to the power of n minus 4 u n minus 4. So this is the inverse transform z transform of this following system. So number 3 is find inverse z transform of the system xz, which is equals to 1 over 1 minus z raised to the power of negative 1 multiply to 1 minus 0.5 z raised to the power of negative 1. So the first step is to multiply this system into z squared from both numerator and denominator. Okay? The next step is to combine this quantity for this equation. Okay? Combine this quantity, we get 1 minus 1.5 z raised to the power of negative 1 plus 0.5 z raised to the power of negative 2. Okay? Then next is distribute z squared into this quadratic equation. Okay? Distribute, so we get z squared minus 1.5z plus 0.5. Okay, we get this. And the next step is to decompose this quadratic equation, which we get a perfect square of, I mean, a equation of z minus 1 multiplied to z minus 0.5. Okay, so the next step is to um, divide um, both equation to z. Okay, divide both equation to z. Okay, we divide this to z, and this also divide to z. Okay, and then the next step is to um, do the solving of partial fraction. Okay, do the solving of we do the solving of partial fraction. Okay, we need to find the a and b constant. Okay, in order to find the a and b constant, we need to um, multiply both equation into this denominator, so that we can cancel this or um, remove this denominator in order to get this equation. Okay, which is g equals a quantity of z minus 0.5 plus b quantity of z minus 1. Okay, we use this equation to this solving. Okay, if z equals 1, so we need to substitute z into which is 1, so we get 1 minus a, the quantity of 1 minus 0.5 plus b 1 minus 1, so this is equals to 0. Okay, then we do the solving, which is a is equals to 2. Okay, and then if z is equals to 0.5, okay, we do the solving. This is equals to 0 because 0.5 minus 0.5 is 0. Okay, we do the solving, we get b equals to negative 1. Okay, so after those partial fraction solving, we substitute this constant into this system or equation. Okay, substitute those. Okay, 2 and negative 1. Okay, then multiply this system or equation to z. Okay, we multiply to z. So if we multiply this into z. This cancels z, which we get 2z over z minus 1 plus negative z over z minus 0.5. Okay, so we find this um, z transform into z transform table. Okay, we find this and we get the inverse z transform of this following, which is 2 un minus 0.5 raised to the power of n un. So this is the inverse z transform of this system. Okay, so number 5 is, the last number is, find x of n if the system xz is equals to z squared over z minus 1, okay, multiplied to z minus 0.5 raised to the power of 2. Okay, so first step is to um, divide both sides of the equation to z. Okay, divide z. This also divide z, which is from here squared, this becomes 1. Okay, so after that we need to do the solving of partial fraction. Okay, partial fraction. Okay, this this is the repeating roots, so we need to decompose this and we add here c. Okay, so this is the partial fraction. Okay, next step is to find the constant, which is a, b, and c. Alright, in order to find the constant, we need to multiply this into this denominator so that we can cancel or remove this denominator, so in order to get this equation, which is z equals to a quantity of z minus 0.5 raised to the power of 2 plus b the quantity of z minus 1 multiplied to z minus 0.5 plus c the quantity of z minus 1. Okay, we use this equation to this solving. Okay, if z is equals to 1, we do the solving. Okay, do the solving, we get a equals to 4. Okay, this is equals to 0, 0. Okay, and if z is equals to 0.5, we do the solving, we get c equals to negative 1. Okay, after that we get those um, solution or um, numbers here, put it here. If z is equals to 0 and e is equals to 4 and c is equals to negative 1, so substitute here all into this equation. Okay, so substitute here, we do the solving here, here, until we get b is equals to negative 4. After that, substitute those constant into this equation. Okay, substitute, so we get 4 over z minus 1 plus negative 4 over z minus 0.5 plus negative 1 over z minus 0.5 raised to the power of 2. Okay, next is multiply this into z so that we can remove this denominator z. Okay, so we get this equation. Okay, get this equation multiplied by z. After that, um, find the inverse z transform of this following, because this is familiar into z transform table. Okay, arrange those which is familiar in z transform table. So we arrange um, um, the constant, which is 4 here, um, transfer in, so arrange this manner. Okay, so we get the um, inverse G transform, which is 4 un minus 4.5 raised to the power of n un minus 2n quantity of 0.5 raised to the power of n un. So this inverse G transform of this following system. So that will be all. Thank you.